Okay, Year 7. Some students have been asking about the final solution to these. So you've had enough time on the number patterns, and some kids are going, how do you do this one? How do you do these two number patterns here? Well, these two number patterns are beyond what you need to do in Year 7. I only put them in as a challenge. So I'm going to give you the solution now. Some people have found out how to get or what the terms are, but they haven't been able to work out an algebraic expression. So let's have a look at these two. Now these are two very famous number patterns, and I'm going to do them diagrammatically. So let's look at the first one. 1. Well, I'm going to represent the 1 with a dot. 4. Well, I'm going to represent that with 4 dots, and I want you to look at the shape I'm getting. Okay. And the next one, 9. So I'm going to represent that with the shape as well. And you can see very quickly what shape I'm getting. And these are what we call square numbers. 4 dots in that square, 9 dots in that square. And then if I did the next one, I'd get 4 lots of 14, 4 lots of 4, which is 16. Now, once you see this diagrammatically, maybe you might be able to understand how you're going to be able to get a formula. But I'm going to come back to that. First, I'm going to go, all right, well, how do I get the next number in the pattern? Now here, this is going up by 3, then this is going up by 5, and then this is going up by 7. So it's going up by the odd numbers. So the next odd number is 9, 16 plus 9, 25. And the next odd number after that is 11, and 25 plus 11 is 36. So here I can write it's going up by consecutive odd numbers. Consecutive just means in a row. I'm running out of room here. I'll just make that a bit bigger. Now the problem is that that doesn't help me because what it's going up by changes, whereas in these other ones it went up by the same amount every time. So it's not going to help me find the 250th number. The 250th. So how am I going to find the 250th without having to find the first 249? Well, let's go back over here. And let's look at our pattern. So this is the first term, and this is the second term, and it's a 2 by 2 square. And this is the third term, and it's a 3 by 3 square. Hopefully now you're seeing something. And this is the fourth term, and it's a 4 by 4 square. Now what do you notice about the numbers? Notice I said 2 by 2, 3 by 3. Well, 2 times 2 will give me 4. And 3 times 3 will give me 9. Let's go back to the first one. It's a 1 by 1 square, so 1 by 1 will give me 1. And 4 by 4 will give me 4. That's for 16. Holy dooly, Mr. Tonkin. Righto. What do we want? The 250th. I'm not going to draw a square 250 by 250. I'm just going to go 250 times 250. I'm going to have to use my calculator for this. 62,500. 62,500. Well, there we go. So 6 to 500. And that is why algebra is so powerful. Because to do that number 250 times would have taken a long time. But the power of algebra, seeing the pattern and being able to jump in there. So let's take this a little bit further. If I have the nth number in the pattern, well, it's just n times n, which, if you remember from your indices, is n squared. So to go here, what do we want? N times n, which equals n squared. Brilliant. Okay, this next pattern is a lot harder, but is the same. So if you think you want to have a go at it, go away, have a go at it, and then come back to the video and see if you can work out, see if you got it right. So what are we going up by? Well, here I'm going up by 2. And then here I'm going up by 3. And then here I'm going up by 4. So the next number, I'll go up by 5, and that'll give me 15. And the next number, I'll go up by 6, and that'll give me 21. So when I go here, I'm just going up by consecutive numbers. And then remember, that just means the next number, consecutive. And they're whole numbers, so we'll say integers. We should probably say positive integers. But again, to get the 250th, I'm going to have to do 249, and I don't want to do that. So here, let's go back and have a look at these patterns. Have a look at these and see if we can work out a pattern. So at any stage when you're doing this, if you want to go along and stop and have a go yourself, I'd do that. So I'm going to give you a picture and then you see if you can work out a way of calculating it. So again, the first number in the pattern, the first number is a dot. The next number in the pattern is 3 dots. The next number in the pattern is 6 dots. And pretty soon you can see what sort of shape we've got here. The next number in the pattern and you can see we've got triangles. Now, if you knew how to find the area of triangles, that might help. But in the end, that's not, it's still a bit hard. This number is quite hard. 1, 3, 6, 10. What did we do over here? We multiplied the two numbers together. Well, let's see what happens when I multiply the two numbers together. 10 times 10 gives me, 4 times 4 gives me 16. So 4 times 4 gives me 16. That's too many. Well, aren't triangles sort of like half a square? Well, not all the time. In this case, if I were to draw the rest of the square, because it's an equilateral triangle, okay, so I suppose I can do half of that. So I can do half of that. So 4 times 4 over 2, that'll give me 8. I'm still not there. But what if I added another 4 for for the line across the middle. Well, that gives me 12. So if I added 4. Hey, but what if I divided that 4 by 2? And that'd give me it. If I squared the number and added the number and divided by 2. Let's see if that works for here. So let's go. 3 times 3 over 2 plus 3 over 2. Well, I know my fractions and I know their so I can go 3 times 3, because I've got a common denominator, plus 3 over 2. Well, 3 times 3 is 9, plus 3 is 12 over 2. Oh my goodness, look at that. Let's try it for 5, because we know 5 is 25, is the fifth number in the pattern, is 15. So let's see if we get 15. So 5 times 5 plus 5 over 2. Well, 5 times 5 is 25, plus 5 is 30, and 30 over 2 is 15. Well, let's do 250. 250 times 250 plus 250 over 2. So we've already got 250, and I'll just add the 250. So I get 62750 over 2, and I have to divide this number by 2. 31375. 31375. So the answer is 31375. And let's have a look at what I do for n. Well, it's n times n plus n all over 2. But we can simplify that, because we know that n times n can be written as n squared plus the n over 2. Now that is extremely hard, and I did not expect anyone in year 7 to be able to get it. So if you were able to get it, can you show your teacher n squared plus n over 2? Show your teacher, because if you were able to do that, you've done magnificently well. And that's the last two there. Remember, you're not meant to be able to do them. They are beyond the scope of what we're doing. They were there as an extension exercise.